Hello. The first time my students see a stoichiometric problem, they have a reward. They do the manipulation of the problem. And then they can see the properties of dihydrogen, dioxygen alone, the gas alone, and in mixture, in the explosive mixture, and then they like the explosive bubbles. On this photo, you see all the materials needed for each group of 2 students. The chemistry reactives are HCl 2 molar solution, magnesium tape, hydrogen peroxide in solution also. We make a dilution with this stock solution, and potassium iodide. And then you need 2 syringes with a stopper, beige stopper, and a small cup white that fits in the syringe, and a cup to put the liquid, 10 milliliters liquid is okay. This is the first stoichiometric problem that my students do with a reward at the end. They can do the real manipulation in class. And the question is, how much magnesium must we put in the syringe to make 50 milliliters of dihydrogen? They learn the resolution of the problem with this. Let's begin the reaction. We take 1.5 centimeter of magnesium tape. It's 0.05 grams of magnesium. We calculate it before with the stoichiometric problem. We roll it up and put it in a small one cap, the white one. It is used each time for the solid reagent. It should reach the bottom of the syringe without being returned. We fill the syringe with water, delicately put the small stopper, and then we let the water flow until the small container arrives in the good direction at the bottom, like a boat in a lock. Then we insert the plunger of the syringe. It's the delicate part. It's important to avoid jerking the syringe so as not to turn over the container of magnesium. The next step is to add the liquid reagent, 5 milliliters of 2 molar HCl solution is aspirated without drawing in air. The cap is put on immediately, and the reaction does not start until the small boat is tipped into the liquid. The reaction is started by shaking the syringe. The sinking of the boat allows the magnesium to meet the acid. We see that the piston rises by itself. We see an effervescence, bubbles on the magnesium, which disappears gradually, and a release of heat. Next, the liquid must be removed. The excess acid and the magnesium chloride form in solution. So we open the syringe and turn it over very quickly downwards, and we must keep it as vertical as possible. Indeed, hydrogen is lighter than air and tends to leave the syringe for the sailing of the lab. We push the piston to eliminate the liquid, and only the liquid. Be careful to keep the gas in the syringe. The syringe containing the dihydrogen is recapped. To observe the combustion of this gas, we prepare soapy water, a little bit of water and a drop of washing up liquid, and we make bubbles in the soapy water with the syringe. We prepare the match to set fire of the soap bubble containing the hydrogen, and we see that it forms a fireball bigger than the bubble. The hydrogen goes to look for its oxidizer, the oxygen of the air. There is no noise. It's not an explosive combustion. A second stoichiometric problem requires the calculation of the necessary concentration of hydrogen peroxide in the 5 milliliters of liquid introduced in the syringe, to obtain again 50 milliliters of gas, oxygen this time. We obtain 0.8 molar, And we have to do a dilution. We calculate also the dilution from the stock solution and made the dilution for the lab. To obtain oxygen, the solid reagent is potassium iodide. We put a little in the white container that is lowered in the syringe. The quantity is not important. It's a catalyst that will accelerate the dismutation of hydrogen peroxide into oxygen and water. We fill the syringe with water, we put the small boat, we make it go down to the bottom of the syringe, and then the plunger is gently inserted without overturning the small boat. We are going to suck up the liquid. This time is 0.8 molar hydrogen peroxide. Again, try to take only the liquid but no air. Put the cap and invert the syringe. The solid catalyst potassium iodide meets the solution, which turns yellow. The reaction is rather slow. It's necessary to help it a little by creating a depression. One sees bubbles forming especially on the rubber of the piston. And we eliminate only the liquid after and not the gas. Takes time. You can let it when you explain the next. Keep the gas and eliminate the liquid. And then with this oxygen you can make bubbles also in soapy water, and you will see that the flame of the match is revived, more brilliant. After looking for the properties of oxygen gas, we have to do the explosion. They like that. You look at the dihydrogen syringe. If it remains 30 milliliters, then we do a stoichiometric problem to calculate how much oxygen is needed to burn the 30 milliliters, and then we add with a little tube between the two syringes the oxygen needed for the hydrogen. A little pipe. We take care to keep the dihydrogen syringe up and vertical. We push and pull the pistons of the syringe with the exact volume up and down, and we make again bubbles, this time with the explosive mixture in soapy water, and we set fire. This time it will explode at once. The noise will be more or less loud depending on the precision of the mixture, and we can use this mixture to launch a mini rocket from a launch pad on a piezoelectric lighter.
Oh putain, c'est énorme.